Hey everyone, now we're going to question 14, the last problem. The question reads, electrons orbiting a nucleus with a charge 13e under the action of a Coulomb force at a radius of 1.22 times 10 to the power negative 10. Calculate the angular velocity of the electron in radians per second. So what do we know in this case? We know the Coulomb force is this, right? So basically we can imagine this as circular motion. We have this nucleus and then we have something orbiting around it. This is basically a point in the middle, right? Because the nucleus is so small compared to the orbit. And we know basically that the Coulomb force is also the centripetal force, right? The Coulomb force is always pointing it towards the center of the circle. And what do we know about the, so let me just write the force of the electric field, or just force of Coulomb, is equal to the force of the centripetal force. And what do we know about the centripetal force? Well, we know that it's mass times omega squared times r, right? So that's what this omega is. This omega is the angular velocity of the electron. So that's what we're going to try to calculate. So what is this? So we are given that the Coulomb force, well, so we can calculate the Coulomb force with what we have. The Coulomb force is constant times the two charges. So the charge is 13 times the charge of electron, which is 1.6 times 10 to the negative 19. Okay, times the charge of the nucleus. Oh wait, hold on. Times the charge of an electron. This is the charge of the nucleus. The charge of an electron is also 1.6 times 10 to the power negative 19 divided by the radius squared, and the radius is 1.22 times 10 to the power negative 10 squared. So this is the force of the electric, so look, the Coulomb force, and that's equal to the mass of the electron. So right, where we're looking at the electron in this case, the electron is the one orbiting. So what is the mass of an electron? Let's search it up. 9.1 times 10 to the negative 31. How do people figure this stuff out? 9.1 times 10 to the negative 31. That's the mass of an electron. Yep. Times the omega squared, again, just what we're looking for, times the radius. So radius we already given is 1.22 times 10 to the negative 10. We can actually simplify this a little bit. We multiply on both sides and we get rid of this squared at the bottom. So let me just plug it all in and see if I get the right answer. Turns out I made a little bit of a mistake. This just that if you're dividing by r on both sides, I don't know why I canceled out the 2. There should just be a cubed instead of a squared. So that's the only thing. But yeah.